Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. Testing mic, 1, 2, 3. Please reply in the chat or you can unmute. Alright, thank you. Okay, alright, Assalamualaikum everyone. Assalamualaikum and very good morning everyone. So, so we will continue the chapter 5, which is on pneumatic and hydraulic actuator. Okay, so before that, let's look at the discussion that we did last week, which is on the 522 solenoid and 523 stroke 2 and 5 stroke 3 solenoid valve. So based on the task that we discussed last week, is that a student need to discuss what are the difference between these two valves, okay, 5 stroke 2 and 5 stroke 3, and what is the routine principle of both valve. So let me just look at the group. Or I just call the names, student name, because it's volunteer, nobody will volunteer. Just look at attendance. Before that, please go to Learn and take the attendance. You know how to take the attendance, right? Okay, right now only 20 students inside, so we have 29, so 9 students. Please do the attendance. Okay, this one should be the normal setting is like I'm not sure if you have been to UTEM before. Have you been to campus before this? Or you have been online since first year? Hello? Hai. Soalan dia, tahu tak soalan dia apa? Aduh, hai.
Tanya yang mana? Yang budak baru tu ke?
Semua orang. Everybody. Okay, everybody. Okay. Have you been to UTEM campus before? No. Yes. Have you been to UTEM campus or have you been inside a class, face-to-face class? Okay, that was a simple question. Okay. So I hope that student can immediately answer lah. I don't have to repeat myself. Okay, no. Thank you very much. Okay, so that I may explain. So basically, alright, if you have a face-to-face class, in the beginning of the class is that I will call for attendance. If we have 60 students, then 60 students will call for attendance at 8 a.m. Alright. So, but because we have online, so students need to do the attendance on their own. So please do the manual attendance as in ULearn. Alright. Very simple instruction. Okay. And please, when I ask question, please do reply. I'm not going to read the chat all the time because I'm doing something else, finding the document. So if you have a mic, then unmute the mic. Very simple. Okay. There's no difference between direct entry student, new student just come in, or the student who already second year. I don't actually differentiate between the student. I assume that you are second year, right? Second year taking this subject. So there should not be any bias lah. So the question is general. Okay. Okay, Loh Yi Chong. Loh Yi Chong. Okay, share the Padlet of your group discussion and then proceed to explain. First is 522 solenoid valve. Alright, so please share the screen. Loh Yi Chong. Alright, please share. Okay, while we wait for Loh to share the screen, okay, I have read the breakout session comment on the last week. So I'm sure there are some positive comment from students. So they like the breakout session discussion, and some who do not like. Okay, so in life we have something like that lah. We like something and we dislike something. So in my class is that we are going to do both. Either you dislike or you like it, then you need to proceed to it. Some students commented that they don't like the breakout session due to the fact that because they can do it on their own. Well, okay. First of all is the lessons of group teamwork. Okay, so that is an important thing that I want to instill in students during undergraduate studies. So group or teamwork is really important later on when you work also. Okay, you are not going to work in silo, you are going to work in a team, okay, with a group of engineers later on. So you cannot work alone. So this is where you need to work together. Okay, I know that there are some students, while I'm waiting for you to share the screen, so please share. So while waiting that, I'm going to explain. So because there are some students who say that okay, they like the breakout session because, well, as you have mentioned just now, okay, you never been to UTEM, you never been to face-to-face class. So this is where I make the platform for students to discuss among themselves, to meet other students, to meet online, on the camera, on your webcam. Okay, imagine okay, sorry, Lo, wait for a while. Imagine if I were delivering the class lessons without switching on my camera. Okay, without switching on the camera. So I'm going to just talk non-stop. Okay, how do you feel? Do you like the communication? Okay, when we communicate with each other, okay, normally we need to have first is communication, two-way communication. That is important. The secondly is eye contact. In this class, basically there's no eye contact. Well, you have eye contact with me, but I do not have eye contact with you guys. I do not know if you are watching or you are listening, or if you are sleeping, just switching on your laptop and sleeping at the side there. Okay? So imagine that. So imagine that later on, when if you are going to have an online class for 4 years, imagine that. Are you going to work in silo, or are you going to try to adapt to working in a group, working as a team? Okay, so this is think about that. Okay, so because you know what happened is that towards the end of the degree, or when you later work, find a job, we find out that student communication skill is out. We go for interview, you cannot communicate well with the interviewer. Okay, I ask question just like this, that let's just now. Okay, I ask question, but student do not answer. So out, communication skill is out. Okay, so bear in mind that please, okay, if the lecturer, not only me, if other lecturer ask question, please answer. Okay, because we have been teaching like for 4 semester online, and it's getting frustrated towards now. It's currently going more and frustrated due to the fact that students do not actually apa ni put effort. Okay, I would say that put effort to unmute the mic, or even put effort to on their video. Okay, I know you most of you are using laptop. Laptop nowadays have camera. So please on your camera. Okay, at least lah. I don't think student like lecturer being this in the morning. No. Okay, so you know, you guys will put a face on the lecturers. You guys will put a smile on me if you open the camera, basically, because I can see a face in front of me. All right, so that's what I'm just going to tell you guys. Reason why the breakout session will still be emphasized in my class. For other class, I do not know how the lecturer is doing their lessons, but for my class is that I want to know that student understood the topic. And how do I get the feedback? Other than the feedback that you fill in the ULearn, okay? If you put there in the ULearn that you understood this topic, okay? If you just simply say that, okay, without putting effort to write the feedback, then I will see the result later on in the midterm and final exam. Either you score or fail. That's all. Okay? So, communication is really important in terms of in breakout session, and if like in Padlet discussion activity, I really would like to see student effort in their discussion in group and their own effort also. Alright? Okay, so having said that, okay, Lo, let's look at, okay, just explain on the 5 to 2 solenoid valve. Alright, please start.
Toto, can you see my screen?
Yes, sure. I can see the screen.
Okay, for the 5/2 solenoid west, there are 5 ports and 2 positions.
5 ports and 2 position. All right. Please explain more.
The first position is port P connected to port A, and port B connected to port R.
What is P? What is P? What is B? What is A? What is R?
They are one of the port.
One of the port. Do you have the diagram for that? It's underneath, right? Can you just scroll down a bit? Yeah, that one. Okay.
Here is the port.
Okay. All right.
And the port T is closed. When the port T is closed, it will no flow of oil in the system.
Okay. All right. So anything else you want to explain on solenoid 5 to
Uh,
valve.
and they are second position. Second position is port P connected to port B and port N connected to port T.
Port T. Okay.
This
Means that
connection this connection will divert flow of oil to the reservoir.
okay, alright. I think I understood that. Okay. But I'm not sure anyone else. Anyone who still do not understand what is the principle of the 522 solenoid valve? Write that in the chat. Understood? Yes, no. Simple je. Yes, no. Yes. Okay. Thank you very much. Low. Okay. Let's continue
Thank you.
to. Okay. Thank you. And please and share. So let's go to the 523 control valve. Okay. 523 control valve. Muhammad Walid. Muhammad Walid. Ada? Okay. Ada. Share the screen. Can you share the screen? I speak but no response. You need to check the setting at the mute underneath the WebEx there. Okay, you have a setting mute there. Okay, there's a drop down. Click on that drop down and go to audio setting. Okay, it's the second last. Okay, audio setting and then go to microphone. Okay, under audio. So just select maybe because you're using earphone or using different earphone sometimes, okay, or speaker. So you changing between some settings, so you need to select the correct microphone. Okay. So can you do that? Can you find the
Hello.
okay. Okay, Waalaikumsalam. Dah boleh dah. Alright. So please share the screen. Walid?
Sorry, I'm not understand exactly about 5-3 wave.
Valve.
Buffer.
Valve. You don't understand
Yeah.
it? Oh, okay. Okay, kalau tak understand then panggil orang lain lah. Okay, Muhammad Azuhairi. Muhammad Azuhairi. If you don't understand full, it's okay. Try, put effort to explain. Because why? In your midterm and in your final exam, you need to answer. Okay, so you cannot skip that. Okay, if you say that you don't understand now, then why don't you make the effort to understand it? Okay. Siapa tadi? Azuhairi Azuhairi. Ada tak? Iqbal?
Yes, sir.
Siapa nak jawab ni?
Hello,
Iqbal.
sir. May I ask to leave the class, please?
To leave the class?
Can I? Yes.
Why?
Doctor in hospital asked me to come and bring home my mother.
Oh, okay. You punya mak masuk hospital ke?
Doktor cakap keadaan dia dah tenat sangat sekarang. Suruh balik pun.
Oh, dah. Okay. Boleh. Boleh,
Thank you,
Iqbal.
doktor.
Okay, saya doakan semoga semua semua okey. Okay, alright. Okay,
Thank you, doktor.
okay. Alright, okay. Selingan lah. Okay, itulah kehidupan Right, we have family, and if you have family, take care of your family, your father, mother, your siblings Alright, siapa tadi? Azuhairi. Azuhairi?
Yes.
Ya.
I cannot share my group.
You cannot share your group. Why?
Wait.
Why you cannot share?
Sister photos. Wait. How to share?
Bawah tu ada share. There's a tab underneath there, right? Ada mute, stop video, share. Click share bawah tu. Share. Then, if you're using one screen, then share je lah satu screen tu. Select je screen tu. Tak perlu nak share. Don't need to select application Renyah. Okay. Share screen saja.
Sebab saya guna iPad Ustaz. Macam mana?
Oh, canggih lah. Saya tak ada iPad
Share.
Saya tak tahulah aku. Kak guna iPad kat mana tu.
Tu dia tak ada pilihan Safari tu. Macam
Pilihan
Google
pula.
tu.
Oh, okay. Alright. Okay lah.
Sorry,
Kita open kepada volunteers I open to volunteers who want to answer.
Sorry Doktor.
Right. Volunteers. Pun tak ada juga. Oh, astagfirullahaladzim. Okay, let me just show to you what's happening on my screen I'm actually taking notes on who actually presented means that presented. So those who already presented, you can skip. But those who never presented, in the end, I will call your name Okay? So any volunteer? If you think that this one is an easy explanation, then why don't you volunteer? Team 2. Team 2, group 2. Nik Syahrul, Nurul Najwa, Nurul Syahira, Teo Kih Ying, Vignesh. Okay. Who want to share screen? Guys, I'm not going to start class if you don't cooperate I'm not going to start class. Okay? We are doing an activity, so please cooperate who's there? Who's that?
Hello.
Yes,
Hello.
yes. Yeah,
Dengar tak?
okay, dengar. State your name sebab I tak tahu siapa yang bercakap banyak sangat. Nick Okay, Nick.
Ya, saya.
Okay, Nick boleh share
Ya,
screen?
saya. Ya.
Nama you Nick apa? Nick.
Syarul Fahmi.
Oh, Khairul Fahmi. Bukan Nick. Nick Syarul. Nick Syarul
Ya, saya. Nik Syarul
Nick
Fahmi.
Syarul Fahmi. Nick Syarul Fahmi. Okay. 5 to 3 pot. Okay.
Ya.
Alright.
Hello.
Yes. Okay. Alright. Okay. Okay, looks good. Okay. So looks interesting. This figure. Okay. Can you explain one by one if you want to explain everything lah. But if you want to explain 5 to 3 pun okay. Right.
Okay. If you can see here, this is a 5 3-way valve, and this is 5 2-way valve.
Okay.
If you see the diagrams, it looks like different, little bit different. Which 5 3 have 3 slot here, and 5 2 have 2 slot. If you see how they going working, for example, if the air we flow here, and that means we go here, and the air we push the solenoid cylinder to pergi keluar.
The right side extend.
Extend. And then the air from here will go out to exhaust.
Okay, all right.
Uh,
So
uh,
that will be the first state,
First stage.
Okay.
This is the second stage, which apa ni, the solenoid with moving to right side, and the air we compress into here, and we pull and pull the solenoid back, and and this air we compress to exhaust.
Okay, all right.
Different
Okay.
different this solenoid 5 per 3 valve have two signal with both sides, different with 5 per 2 way valve, which it have one signal only. Right?
What do you mean one? What do you mean one by one signal?
Kalau tengok dekat apa tu yang valve ni, dia kiri kanan dia ada signal, maksudnya kalau dia terima sini satu digital signal satu, dia akan menolak pergi sana.
Means
Apa
that
tu?
what you mean is that for the 5 to 3 way valve have two solenoid, right? Two solenoid.
Yes.
Okay. For 4 to 2 way valve, you have one solenoid. That's why you say
Yes.
one signal.
Signal.
Okay.
Yes.
All right.
Because-
Good. Anything
Okay.
else?
Thank you.
Okay, tak ada. Okay, thank you very much, Nick. Okay, let me just elaborate on what your friend has explained. So basically, what your friend explained just now was very good, I would say, for Lo and also for Nick. Okay, so let me just go through a recap, very fast recap what you have learned last week. So you have learned that in pneumatic system or in hydraulic, you have three main components. First one is that you have the air preparation system, or when we talk about liquid, then liquid preparation system. So basically, it's the same for pneumatic and hydraulic. So basically, what I'm going to cover when I talk about this general complete system is that for both hydraulic and pneumatic. So you have learned that you have the air preparation system for the first part. And then, secondly, after going through all the parts of the air preparation, from compressing the air until filtering, lubricating it, and then regulate it, then you have the air going out from the tube. Okay, and then it's going to go into a control valve. Okay, or normally this one, the whole thing we call as the valve. Okay, directional control valve. And normally this airflow is something that we put here before the valve, is that to add a sensor. So the sensor can actually read what is the pressure, okay, from the air preparation system before going into the directional control valve. Okay, you put a sensor over here, okay, to control the airflow, basically. Okay, and then what you have here is that the air will go into the valve, like what your friend explained just now. Okay, the common one that people use is the 5 to 3 and 5 to 2. Okay, valve. Okay, directional valve. So what's the difference? There are different between these two valves. Even though it's look almost the same, it has 5 port, 5 port, but it has different state or different position. Okay, so later I will explain that, but basically what your friend explained, Lo, and also Nick explained was ample enough. Means that they understood the principle of those two valves. Okay, and from there is that this one is, we call it as the inlet, the air inlet into the valve. Okay, and there will be two output, means that output inlet, output air, okay, going out from the control valve. So this output air is being controlled by the valve. Okay, valve is basically like, you know, the pipe lah, pipe. Normally you will turn the pipe on and off, to 0 or 1. Okay, on, off. So basically valve is something like that. But you are going to control the valve using a signal. So that signal is from this controller, or we call it as the board lah. Okay, so that's why you see that you have a analog out going in here, okay, and digital out going out. So analog out, why? Okay, remember last time we have talked about in the basic control. Basic control is, okay, look at this one. We are talking about the actuation system right now. And then we talk about the hydraulic and pneumatic. And you see that we have the D to A and D to D converter. Oh, sorry, and A to D converter. So basically, the one from the controller is the D to A. So you're going to convert the digital to analog. And when you are going to give the output to an actuator, to this actuator, is that you are going to convert from digital, this signal is digital, and this signal read by the actuator is in analog. Okay, and of course, the form outside, out from the actuator will be an analog signal. And most of the time when you have the analog signal is that you can actually apply it to any sensor or any display unit. So going back to the slide just now, okay, so you see that we have the analog out, which is basically the signal from the DSP board. Okay, DSP board is digital, so that's why you need to have a D to A converter. So convert it first to analog signal so that this valve can read. Okay, it can only read analog signal. Okay? And then when you read analog signal, basically you can control the air between this inlet outlet, outlet 1 or outlet 2. And that signal also can be read again. Okay, either it's open or not by a signal which is sent back to the controller board. Okay, so you have an analog to digital here. So that's why you have a digital to analog and analog to digital in between a controller and a actuator or a sensor. Yep. And then this air will be insert or be pressurized and being input to the pneumatic hydraulic actuator. So basically, it's going to be one off, one on and one off. So the state will be on, off, on, off. It cannot be both on at the same time. Okay, it can be off. Well, it can be off at the same time. Where we can use the on, off at the same time is where when you use, okay, if for example, if you are using, okay, for example, if we, let's say that this is port 1 and this is port 2, okay, for 5 to 3, you can use 0, 0. The state is 0, 0, means that there's no signal, then the pneumatic actuator won't move, okay. For the 5 to 2 port is that it's either 1, 0, 1 or 0, sorry, 1, 0 or 0, 1. And this state, it can be 0, 1, 1, 0 and 0, 1. So you see that there are 3 states here. And there are 2 states there. Okay? Underneath here. So that's why we call it as a 5 to 3. Means that you have 3 states for that 5 to 3 valve. Okay? And for the 5 to 2 valve, you have only 2 states, on and off. It cannot be off at the same time. Okay? So, clear? Everybody clear on that? If you're not clear, please write that in the chat. Yes, no? Okay, clear, Okay, so to make your life more clear on it, okay, so I'm going to explain more on the air preparation system, even though you have also watched it in a video, okay? Just to recap, okay, for the air preparation system, that you have 3 component in the air preparation system. Mostly they call it as the FRL. Okay, so what is F? What is R? What is L? So F is filter. Okay, so you have the filter in the first part of the air preparation. So basically, if you look at this diagram, this is air from the compressor, air going in. Okay, so it's going to go into the filter. So filter basically filter out the dust. Okay, dust and so on. Okay, and then next is go to the regulator. So the regulator is going to regulate the pressure at what value. So we see that there's a reading here, the regulator display, and this is a knob over here on top. So this knob can be turned clockwise or anti-clockwise. So you turn the knob, okay, turn the knob anti-clockwise or clockwise to adjust the pressure. It's like similar when you are going to the what petrol station. You want to pump your tire, kan? To adjust the pressure because different car have different pressure for the tire. So, for example, the car for SUV is different. For the car for MPV is different. The car for the pressure for a bicycle or motorcycle is different pressure. So you need to adjust. So this is where you have the regulator for the second part. And the third part is that lubrication. Okay. So what is lubrication? So because you already filter, right, the air, so why do you need lubrication? So lubrication is basically to make sure that the air is moist. Okay, it's not dry. Because why? When you have a dry air, means that it's going to have wear and tear. Easily wear and tear. That's why you need to have a lubrication oil. Means that you're going to lubricate, moisturize the air. Okay, at a certain value. So you have the lubrication. Okay, so this is the three common component of the FRL. Okay, filter, regulator, and lubrication. Okay, so after you have gone through that, you already have pressure, for example, at 1.5 psi. Okay, psi is the value for pressure. Okay, so you're going to flow it, insert it into the valve, the control valve over here. So this is where you have the control valve that your friend explained just now. The 5 to 3 control valve and the 5 to 2 control valve. Right? So according to an application, to any application that you want, so you might want only the 5 to 2 valve. Okay? But some application you might need the 5 to 3 control valve because at some condition you don't want the actuator to move, so you want it to stop, so there's no movement, therefore you need to use the 0 and 0 state. Okay, so based on that you can control the airflow either to port number 1 or port number 2. Alright, so this is the basic concept of pneumatic system, or even for hydraulic, it's the same. Assembly of pneumatic, I think I have showed that before. Okay, I'm going to show you an example of where this is really important later on. Example of my final year project. This one example of my final year project, last semester student, Vicky. Her name is Vicky Chong. Okay. So let me just find her slide. Where's the slide? Weekly progress. Okay, I want to show you in real life lah. Basically, when you are doing your final project or IDP project, you might want to use a pneumatic system or hydraulic system. So at least you know how to actually connect all the connection, the valve, the pressure signal, okay, the from FRL to the directional valve, and then connect it to the actuator. So this is my student last time. She's doing the design of a motion controller for an active quarter car suspension system. So basically what she's doing was, okay, you have a car right now, you have car. So quarter car means that, okay, if you can look at a car like this and you have the tire. Okay, the tire, this is top view. I'm just going to draw a very simple sketch. Okay, so quarter car means that you are taking this half part only, one part of tire. So the student is doing modeling on that one part quarter car of the quarter car of the modeling. Okay, so we have the mass spring damper component over there. So her objective is actually to control the car, okay, when it's going to move in a pothole, example like this, pothole or illegal bump. Very illegal bump means that a very high bump. Okay, so you want the car to be stable. Means that when you go through a pothole, it's not going to be bumpy, right, for the passenger or for the driver. It's going to be smooth even though there's a pothole. So this was her project about that, to design a controller for a quarter car suspension system. So you might ask, what's the use of designing a quarter car? Because a real car have 4 tires, 4 parts, 4 tires part. Well, before you can apply that to a full car, okay, so you need to at least evaluate the modeling of a quarter car first. If the quarter car is success, then you can apply, just duplicate it to 4 parts, then you combine it, then you can control the car later on. Okay, so this quarter car suspension system is the first step. Okay, and she's doing experimental work and also simulation. Okay, and bear with me, bear with me that my class is not normal teaching on theory, boring stuff on theory. If theory, I will ask you to read the book. Okay, I will actually relate to the reality of you guys doing your mechatronic engineering degree. Means that when you go for your final year project, what will you expect later on? When you do for your IDP project, what you should expect. Right? So let's look at. Okay, this one is the setup of the quarter car. It doesn't look like a car lah. Basically, there's no tire. But we are going to model the system by using mass, spring, and damper. So you can see that the M1 here, okay, represent the car body, M1. M2 is represent the car wheel, okay. And R here, the mass underneath here is representing the road. Okay, so imagine that what you're going to control is that M2. You want to control the damping of it. So road is that you just apply any motion to it, and we want to maintain M1 at the stable position. M2 is going to move because it's the tire. Okay, so you want to control that. And what I want to show to you is actually the connection. Okay, how she did the connection. If you see here is that, okay, imagine that there's a car wheel, and the road surface, and she's using actuator. Basically, she's using the pneumatic actuator to model the system. So when she's using the actuator, is that she's using 2 different actuator. Okay, one actuator is representing the wheel, and another actuator is representing the road. So how she's going to connect it is that, okay, let's look at the starting point over here. Okay, starting point down here, down here. So you see that there's an air compressor. So it's basically what you have watched in the video and what I explained just now. So it comes back into the compressor. The first part will be the compressor. Okay, the compressor is going to go into the pressure regulator. So basically this one is the FRL. Okay, it's going to go into FRL. Same thing, air compressor, FRL. So basically it's the same part lah. If I were to use it, it's going to be same part. No need this one because she's using one FRL only at the lab. Okay, and then sorry, I think 1 or 2 sorry. So basically she's using 2 FRL. So there are 2 FRL, FRL1 and FRL2. Okay, and then you see here that she's using the 3-to-2 control valve. 3-to-2 control valve. So basically 3-to-2 control valve, like I said, it has 3 state. 3 state ni apa? Bukan negeri State adalah condition. 3 condition. What was the 3 condition? It's 0, 0. First condition. Second condition is 0, 1. Third condition is 1 and 0. So basically, you want to apply sometimes to the system is that you don't want any signal to the actuator. So you apply 0, 0. Okay. So that's why sometimes you want to use the 5-to-3 control valve. Okay. But for a normal system, if it's just to actually extend and retract an open loop system, extend, retract, then you can use the 5-to-2 control valve. So, but normally, when we talk about controller, you want to design a controller for a system, then it's best to use the 5-to-3 control valve. Because when you have a controller is that, best controller is that you can control the error to 0. So, means that if the error is 0, means there is no input signal to the system. So, that's why you need to use the 5-to-3 control valve. Okay. So, So this is the air going into the pressure sense from the control valve into the actuator. And you can see that there's a pressure sensor. The pressure sensor is reading, okay? It's also connected to the control valve. It's going to read what is the value of pressure given to the actuator. Okay, so this is a complete system. So indicate that you have one for the wheel and one for the road, and she has additional sensor to actually detect the displacement of the car wheel, displacement of the body of the car, and also displacement of the road. How much displacement is given to the pothole, depth of the pothole. All right. So that's a little bit of sharing on a real system. Okay. So let me just wait for a while. Let me just continue. Okay. Okay, so now let's look at the 5-3 and 5-2 valve. Okay, this one is already explained by your friend, but for the sake of just sharing again, since I already prepared, so let's look at 5-2 valve. Okay, so 5-2 valve, the one that I showed in the screen here. Okay, 5-2 valve is, okay, you can see that basically you have 5 means that you have 5 port. 5 port means what? So it means that you have 5 ports lah. Ports. 2 ports are for the input. Sorry, 1 port is for the pressure. 2 ports is for the output. Okay. And 2 more ports is for the exhaust. Okay. Exhaust port. Okay, so basically 5 port. And 2 is determined by the state. Okay, state or position or condition. Okay, so what does it mean? If you look at this figure here, this figure shows a 5-2 directional control valve. And you can see that in the position or state number 1 is that, okay, this spool, we call this the middle part is the spool. This spool is actually being given a pressure is and the signal, okay, or the pressure is moving like this, moving in, okay, and is going to go out from the exhaust port. Okay, so basically you have 2 port only active and another port is closed. Okay, so you have 2 state, and another port is that same thing, you have in here and out here. So this only indicate that you have 2 states only. Okay, and if we look at the symbol, symbol of the 5-2 valve, right? So the symbol for 5-2 valve, normally, if you look at the symbol, it will show to you that you have 1, 2, 3, 4, 5, 5 ports. And then you have another part here on the left side, okay, but it's not being numbered. Okay, so it means that directly you can see that there is actually 2 states, state number 1 and state number 2. And on the right side here, the output, not output, the right side here, it indicates the symbol of a spring. So it's a spring over here, means that you know that if you look at the data sheet and it shows to you that, oh, there's a spring here, means that you know that, oh, this is a 5-2 port whereby it's being activated on the right side with a spring. Okay, and how it's being activated is that it's using a solenoid. So this is a symbol of the solenoid. Okay, so this solenoid is being sent here lah, on the right side, left side. Okay, so okay, let's look at a real example of a real valve. So let's look at this first solenoid. There is 2 types of solenoid I give here. Okay, both are Festo. Festo is a very very good brand of a valve for pneumatic system. So you have Festo here, and both are solenoid valve lah, basically. Okay, solenoid valve and pneumatic valve is the same thing. So, but if you see here, the code is different. JMFH 5, blah blah blah, and so on, and VL, blah blah, and so on. But you do not know what is the the condition or the characteristic of that valve. So what you need to do is that you need to look at the data sheet. So let's look at the data sheet. Okay. Oh, before that, okay. Before we go to that data sheet, okay, on the right side here, there is two symbols. Okay. First symbol shows this type of valve, and second one shows this one. Okay. So which of the two is a 523, and which of the two symbol is 522 control valve? Okay. So please write in the chat, what do you think? Which one is the 5? Just right there. 523 is number 1. 522 is number 2. Example lah. So write that in the chat. This is a question since I explained just now. Okay. Alright. If you can answer this, then mean you understood my explanation just now. Okay. 522. 522. 522. 522. 522 is number 1. Okay. Most of you answer correctly. Okay. So 522 is number 1. Why? Like I mentioned just now. Okay. You can look at this type of symbol. You can see that there are two states. So basically, if you look at here, you can see that an arrow going in from this part 1 to 2 and going back. So this one we call it as the first state. And you can see that there's another arrow going in and out. Then you know that it's the second state. So basically, this one is the 522 valve. And the second symbol is basically the 523 valve. Why? Because you see that there is a first state here. This one will be second state, and third one is be the third state. And you can see here is that the middle state is basically the one with the 0, 0 state. There's no any movement to the if you are connect it to the actuator, because there is no signal going out. Okay, the signal is 0. Alright, and another question. Okay, so if you see in the first part, what type of component that you can see? You can see that there's a spring. What else? You can see there's a solenoid. Okay. What is the symbol? What is the symbol? Anyone? Anyone?
Lupa. Rasa
Apa dia? What is it? If you read the Bolton book, if you go through the Bolton book, actually is in there. So I know that you didn't go through the Bolton book then. Okay. What is the symbol? Okay. If you go to the Bolton book, okay, you can see there's a symbol here, symbol. So you can see that there's an actuation valve symbol. It's either by spring, by solenoid just now, and this one is by pressure. Okay, application by pressure means that without using solenoid or signal. So there are different types of actuation symbol also. It can be the valve be activated by a roller, okay, by a lever. By a lever means that on-off switch lah macam tu. And then by a plunger, okay, by push button also it can be able to switch on and off. Okay, but most of the time when we talk about mechatronic system, normally it will be activated by pneumatic pressure or by a solenoid. Okay, and also if you see here, okay, it's really related to what you have learned on the symbol. Okay, you see that there's a flow path. Flow path, flow shutdown, and initial connection. So the arrow connection is showing that there's a flow path, and then you know that there is actually two state over here. And for the another path is that you see that also there's a arrow, okay, and if it's blocked like this, that means that there is no connection, is being shut off, okay, means that it's actually shut off when because when you have a 5 port, then one of the port will be closed. And above here, if you see the valve switching position, okay, so this really indicate what is the state of the valve. So you have only one block, means that one state, two block means that two state, and three block means that three state. That's why you get this one is 5 to 3 control valve. Okay, right. Okay, now let's go. Okay, I didn't share yet this one. Okay, siapa tu? Syafiq. Offkan mic you
Lupa.
Okay, offkan mic Okay. So this one is example of solenoid valve, the one that I took just now. Okay. And basically, I took the example of the symbol from the datasheet. Okay, from datasheet. And you can see that it mentioned in the datasheet what type of valve it is. Okay, valve function is 522 double solenoid. So why it is double solenoid? Because you see here, at the end here is 2 solenoid. So double solenoid without any spring. Okay, for this type of valve, they don't use any spring. Okay, and that's why because sometimes 522 is normally they use 522 with the spring. Okay, but for the case of double solenoid, then they don't use any spring. And you can look at what are the features, additional features that they have. So they have the switching, the frequency, switching time reversal 12 millisecond. The maximum positive pulse is about 2.2 nanosecond. Very fast. Means that if you are to buy this valve, it's very expensive. And it also gives you the temperature of the valve. Okay, at what rate that it can read. Okay, and let me see if it gives you the pressure. Normally it gives you the pressure. Okay, here it gives you the maximum operating pressure. So the operating pressure that it can read is either in bar or millipascal. So it's in between 2 bar to 8 bar, and from 0.2 millipascal to 0.8 millipascal. Right? So this is how you read a data sheet. Okay, and another data sheet. Okay, this is another data sheet. Okay, and this other data sheet is that you have look at the end part. Okay, this is the 5 to 3. Directly, if you look at the symbol, you know that it's a 5 to 3. And is being initiated by pressure, not solenoid. This is a symbol of pressure, tadi, air pressure. And it's using 2 spring at the end. Since it's not using solenoid, then it need to have a spring to retract the valve. Okay, so you see that the feature there, the valve function is the 5 to 3 pressurized. So because of the 2 pressure at the end there, and a pneumatic type. Okay, and the bar operating pressure, okay, this one is a bit higher. Okay, operating pressure is between minus 0.9 bar, means that it can read until negative, and until 10 bar. So this is more expensive lah. If I directly look at this, it's more expensive. And then I think you can just go through so this is very interesting way on how to actually select what type of valve. Okay, now for this case is that I'm going to skip this. Basically, it's already explained in the video. So for the air preparation is that how it's going to prepare the air is simply same explanation as this and this. Okay, so you can just read this through, and it's in the textbook Bolton. Okay, and this is on what are the different? Okay, we were talking about previously on the valve only. Up until valve means that we already went through the air preparation system. And then next step is the pneumatic cylinder, or we call it as the single acting or double acting cylinder. Okay, so the double pneumatic actuator, there are two types. One is the one direction motion, means that it's all going to extend. And most of the time when you have one direction motion, there will be a spring here at the end. Sorry, it's not right. Okay, there's a spring at the end here. So after you actually cut off the signal, then this will be moved back. The piston will move back into the actuator. Okay, so it's going to do a reciprocating motion. Okay, reciprocating motion. Okay, what's the difference between reciprocating motion and oscillation motion? What's the difference? Okay, even though this one will be learned in the chapter 7, section 6, mechanical actuator, but I just want to ask you this question. So what does it mean by reciprocating motion? And what does it mean by oscillation? Any idea? Reciprocating motion. Repetitive motion. Oh, correct. Okay, correct, Divian. Repetitive motion means that, okay, when we talk about reciprocating motion, is something as extended of a linear motion. Okay, linear motion is only one way. Okay, when the motion is going to be repeating left and right, left and right, left, right, left, right. So you have this type of reciprocating motion. Then we call it as a repetitive motion, left, right, left, right. Okay, so pneumatic actuator or hydraulic, it can do a reciprocating motion based on the signal that is given to the actuator. And that signal is being controlled by the directional control valve. Yeah? And oscillation is a bit different. Oscillation is something like this. Okay, oscillating. Okay, oscillating is when you have a sine wave. Okay, so it's going to oscillate from point A to point B. And again, so it's going to oscillate. So oscillate is with a degree. Okay, with a degree here. What angle is it? So this is oscillation. So that's the difference. Okay, so for a pneumatic actuator, for one directional actuator, okay, let's look at the video. I hope you have seen the video. Is this correct? Kejap Pneumatic cylinder. Oh, skip. Iklan rupanya. No voice. Okay, basically, I'm going to explain this. So basically, what you see is that the inside of a pneumatic actuator. So the inside part, you have the piston rod here. Okay. So when you have the piston rod here, it's going to be either extended or retracting. Extended means that dia keluar daripada actuator tu, extending the motion. And retracting means that it's going to shorten the motion. Okay, and normally the part that we actually we link the end part to a table, to a load and something to move it. Okay, so if you look at, if I fast forward it, so basically you have the control valve here connected to the both ends of the pneumatic actuator. You have the one port here and another port here. Okay. And for those two ports is that what you have learned is you have the 5 to 3 and 5 to 2 valve. Okay, so I'm going to skip that. So basically, if you were to apply the control signal to this port, then flow will go through this point. Okay, air will be pressurized at this end, and what happens is that the piston rod will extend. Okay, so this is what happened, and the air, of course, in that part will move out through this point B to S through exhaust port. So it's going to let out the air outside, and it's going to repeat again when you apply it in this direction. Okay, for example, if you control the signal to this point, okay, you give the signal so that air goes to this point. Okay, air will pressurize inside here. The air inside here will exhaust, go out at the left part, and then the rod will be retracting. So this one is a pneumatic actuator, and the video that I showed to you is basically a double acting actuator. Okay, it's not a single acting actuator. Double acting actuator. Double acting actuator is that you have two ports, you can control two ports. And how you control that two port is that you control the signal to the control valve. Yeah. Okay, so basically this one is the second one. You have the compressed air and then compressed air. Both air can be inserted to this point. For the single acting cylinder, there is only one port that you are going to give air into. Okay, the actuator at the compressed air only. And another port is that it's going to go out. Okay, so for the case of this single acting actuator, do you think that you need to use a control valve? The question to student. Do you need to use a control valve, directional control valve for a single acting cylinder? Soalan dalam bahasa Melayu Soalan dalam bahasa Melayu adalah, adakah anda memerlukan control valve untuk single acting cylinder? Yes or no? Tashini cakap no. Chu cakap no. Muhammad Izul, it's needed. Yes lah kot. Nur Afikah, no. Yes, if rich. Rich tu apa? Saya tak faham. Nick, saya tak faham. Tio, yes. Deviant, yes. So, there are combination of answer from student. Okay. My answer is that if you are using one directional motion, okay, it's depending on the application that you want to use. But normal application for open loop, you don't need, it's not necessary to use the directional control valve. It's not necessary. Reason why? Okay, if you look at the control valve just now, control valve ni dia ada 3 port, 5 port. So basically you have 2 output port and you have 2 exhaust port and 2 input port. Okay, so let's look like this lah. So 2 output port basically is going to go to the pneumatic actuator, P lah. Let's assume that P is pneumatic actuator, the inlet here. So for the one directional motion port, you only have one port only, one inlet, okay, to actually send the compressed air. So therefore, it's actually not necessary for you to use a control valve. Not necessary. Okay. But if for the sake of, for example, you want to have the control valve to control it at a different, how much pressure you want to give it, or how much time you want to give the pressure to the actuator, then you can use a control valve. And the end part of another port here, you need to close it. Okay. So there are some condition that you might want to use a control valve. Okay. But for the example of a double acting cylinder, you must use a control valve. Okay? Must use a control valve. Why? Because you see that there are 2 ports that you are going to apply the compressed pressure. So, control valve is necessary. Okay? It's either 5 to 2 or 5 to 3, depending on your application. Okay? So, I hope that's clear. So, let's look at this video. Okay, before I share that, okay, because our next task in the Padlet is, sekejap where's the Padlet? Next task in the Padlet is, okay, how many methods, okay, are there to control the speed of the pneumatic cylinder? Explain the pro and cons of each method. So basically, for this, to answer that question, you should watch this video first, eh? So that's why I didn't ask you to answer in the Padlet, but it's okay if you already answer. So this one is the question. Do you hear anything? Kenapa tak ada? Sekejap I will check sound setting. Oh, okay. No wonder.
As far as controlling the speed.
Can you hear the video? Can you hear the video?
Yes.
Okay,
Yes,
okay.
sir.
Alright. I will play the video, eh. Okay. Listen properly. Jot down each of the question was, okay. Okay. How many methods are there to control the speed of the pneumatic cylinder? Okay. So, for example, if there is 2, what is it? And what are the pro and cons? If there is 3, what is it? What is the pro and cons? Okay. And like some of the student asked, okay, maybe for this question is that no need to do a breakout session, but student need to do it individually and upload your answer. So what I want you to do is that while watching, okay, take out a piece of pen and paper, or if you're using tablet, then just write out your answer. And then upload it directly after finishing the video. Then I give you 1 minute to take a photo and upload it in the Padlet. So there's no time. Directly when you watch, please take note. Alright, so let's start.
Hey guys, Scott from Freight Props here, and today we are going to be talking about controlling the speed of a pneumatic cylinder. So we have a couple cylinders set up here with a couple options as far as controlling the speed. We get this question pretty frequently, like, how do I control how fast my cylinder moves? Can I make it go faster? Can I slow it down? And the answer is yes, and here are a couple ways you can do that. So first up, we have a standard double-acting cylinder, and this is just the standard setup. You have the elbows going into the ports here, and if we activate it, you'll see it activates at basically a standard speed. Now let's say you wanted to slow that down. You wanted the cylinder to extend more slowly or retract more slowly. To do that, you would use flow control fittings, which we have installed on the second cylinder here. As you can see, these fittings have a needle valve, a dial that you can turn in order to meter the flow of air going into the cylinder. So as you turn the needle valve and tighten up the passage of air through the fitting, the cylinder will extend and retract more slowly. Now, because these are double-acting cylinders, that basically means that air both pushes the cylinder rod out and draws it back in. So you can actually control independently the speed of the extension and retraction. So if we wanted to meter down very low the extension speed, we would just tighten this valve down. You see it extends very slowly. We can even go more slowly into extremely slow, probably too slow. You can set this at whatever you want, whatever speed works for your application. So if you wanted your cylinder to extend slowly and retract more quickly, you could do that using these flow controls. Or if you wanted it to extend quickly and retract more slowly, you would simply tighten the needle dial on the rear cylinder port and open it up at the front. So by adjusting how far these needle valves are threaded down, you can adjust the speed of the cylinder rod as it extends and retracts. One thing to note about controlling the cylinder speed is that although you can control and set the speed going in and out, you can't change it mid-stroke. So you can't have it start slow and then go fast. It's going to be set at one standard speed, and that's just the speed that it's going to operate at once you have it dialed in. So here we can compare a cylinder that is not metered at all to one that we have flow control fittings on and see the difference in speed we can achieve. So we see that it's easy to slow a cylinder down, but what if you want to speed it up? What if the speed of the cylinder by default is not fast enough? You want to get more quick movements out of it. Well, that's where something called a quick exhaust valve comes into play. Quick exhaust valve is essentially a valve that attaches to the cylinder ports. This is one detached here. It has 3 ports of its own. So it has one port that connects to the cylinder, another exhaust port, and then the third port where the air goes into the cylinder. Now, how this works is that traditionally, when a cylinder receives air from the solenoid, the air comes into the cylinder, pushes the rod out, and then it has to exit again, back down the air line, all the way to the exhaust on the valve. By using a quick exhaust valve, the air is allowed to exhaust directly at the cylinder connection, which makes it much more fast. So let's check that out. So you can see the cylinder extends and retracts much more quickly. Here we can compare a cylinder that has no quick exhaust valves with one that does. And this cylinder stroke is only about 6 inches, so it's not as noticeable, but when you get up to much longer strokes, it's much more noticeable. It's also possible to much more quickly extend and retract the cylinder rapidly with the quick exhaust valves. For instance, you can create a program where the cylinder very quickly moves in and out. Much more difficult to do without quick exhaust valves. Another way to control the speed of a cylinder is that by rather than adjusting the flow of air at the cylinder ports themselves with flow control fittings here, you can control the flow of air at the solenoid exhaust ports here. This works by restricting the flow of air as it passes back from the cylinder out the exhaust of the solenoid. You can meter it here rather than metering it as it comes into the solenoid. They both accomplish the same effect, just at different places. Oftentimes, prop makers prefer to use speed control mufflers because the cylinder itself may be inaccessible. It could be attached to a mech or inside a prop. So it's easier to locate the flow controls on the solenoid itself, which can be located away from the prop and easily adjusted from a distance while you observe the prop's motions. Flow control mufflers work exactly the same as flow control fittings that mount to the cylinder. You can simply change the depth of the needle valve to control the speed of the cylinder. If we want that to extend more slowly, simply dial down the valve, and it should extend more slowly now. Because this is a double-acting valve and a double-acting cylinder, you can control the speed, both of the extension and retraction, on the solenoid itself. Because this solenoid has 5 ports, it has 2 exhaust ports, one for each output. So you can control the exhaust speed of output A with exhaust A, and the exhaust speed of output B with exhaust B, thereby controlling both the extension and retraction of the cylinder. So that's a quick example of some various ways to control the speed of a cylinder.
Okay. All right. So, okay. Hello. Okay. So you have listened to the video, right? Okay. Is it okay? And I hope that you already watched the video because it's already, I gave the link in the PDF, so you should be able to click on the link and watch it before class lah. Okay. But anyway, okay, I give you roughly about 5 minutes, 8 minutes, until 10:30. Okay, whatever that you jot down, okay, take a photo, scan it, and upload to this task here. Alright? Okay, so we take a break also. We start back at 10:30. While taking a break, please upload your answer to this Padlet. Alright? Okay. Alright. Have you upload your answer? Mm. Mm. Okay. Anyone can explain what are the? Anyone want to share? Any volunteer want to share their answer? Volunteers? Yes. Sabtu yes, bukan. Tan Shini,
Yes, doctor.
can you share your answer?
But I can't share my screen now.
Oh, you cannot share. Wait.
Yeah.
I try to
Because I
open
using
for you.
phone.
Oh, using phone. You can share your screen using phone. You know how to share. But anyway, okay, I already share for you. Okay, so can you explain your answer?
Okay, wait.
I already share the screen for you.
In the video they got two
Mm-hmm.
you choose method to control the speed of the phenomenon cylinder. One
Mm-hmm.
is flow control fitting,
Mm-hmm. Mm-hmm.
and one is quick access. Well,
Mm-hmm.
the pro for the flow control is it have neither range that we can turn to adjust for the flow of the air.
Mm-hmm.
But the con for it is
Mm-hmm.
it can change the mind, so it cannot start it the slowly and then go too fast.
Mm.
For the quick source, well, can and extend and extract much more quickly,
Mm-hmm.
and then it can get more noticeable when we control the speed. And we can also control the flow of air
Mm-hmm.
by adjust the meter. But it will produce noise when we use it, and it is expensive. And that's all for me.
Okay. Alright. So only two, Tan? Only two. I think there were
Yeah.
more. I think there were more. Wait, I already closed the video just now. Sekejap,
Hey guys.
Okay. So if you look at this video, okay, let me just explain. I think there were more than two. Okay, the first one, if you look at the down part, is that he only have the pneumatic actuator, which is connected to the airflow. Okay, so by doing that is that he control only the pressure, air pressure from the valve. So giving 0101 lah basically. Okay, 0101, and then the pneumatic actuator will extend and retract. Okay, that one is the first one. But you cannot really control the speed of the extending of the piston. Okay, so that's why in the second part is that he have the needle valve, right? Needle valve is actually attached at the input port here. So what happens is that the needle valve is that you adjust how much that the air going into the pneumatic actuator. Okay, so if it's clockwise until full, then it's going to the piston will actually extend slowly and retract slowly. If you lose it more, then it's going to retract and extend much more faster. Okay, that one is the first way how to control the speed. Second way is that by attaching an exhaust valve here directly at the port of the pneumatic actuator at port 1 and port 2. Okay, so exhaust valve is also the same way how to control it, because you know that when air pressure is going into the actuator, you need to release it back into the air, which is through the exhaust valve. So this is the reason why you can actually control the speed through the exhaust valve. So if you release it much more faster, then the actuator will move much more faster speed. Okay, and if you look at this exhaust valve, actually this is what you have seen in this control valve. In this previously, you actually have the exhaust valve here at the here. Okay, exhaust valve here at this point. Okay, if you look at the 5 to 3, 5 to 3, where was the slide? Okay, 5 to 3 ni, 5 to 2, 5 to 3. So you have the exhaust valve at the end here. So that exhaust valve is important for you to control the speed. So if you have a valve like this, 5 to 2 and 5 to 2, 5 to 3 and 5 to 2, basically you can control the speed. Right? And I think towards the end, he shared to you another setup where you have the control valve. I think this control valve. Okay, can you wait for a while? Okay. Okay, so that two ways, plus another way is that by directly connecting to the control valve, okay, direction control valve. So you should have three answers how to actually control the pneumatic actuator. And FYI, any students are actually in campus. If there is any student who are in campus, I actually plan if you are doing face-to-face class, normally I will bring student to the research lab and I will explain all of this. Means the example of pneumatic actuator, where is the FRL, where is the type of actuator, where is the valve, control valve, and so on. And if for example later on when we talk about mechanical actuator, then I will show you a real example where we have mechanical actuator in a experimental setup. Okay, so anyone are actually in campus, maybe I can actually bring a few of the student to go to like a visit to the research lab. Anyone in campus? Kalau ada, just write yes in campus. Okay.
Yes, me, Najwa.
Oh, Najwa ada dalam campus. Okay. So, ada lagi yang lain? Ada berapa orang in campus? No, seorang aja. Najwa nanti contact saya special treatment lah. But the other student, I will try to take a video lah and show to you where is all this in the research lab. Okay, so let's continue. Let's continue with the slide. Actually, the slide is nothing much. Already finished. We already covered everything. If you look at the bottom text, basically pneumatic and hydraulic actuator, we talk about the general setup of the actuator, how you actually compress the air, compress the hydraulic. So basically, I don't actually explain about the hydraulic, how to compress it, because it's same way how the pneumatic system is. So, and next one is about the control valve. So in hydraulic also we have the control valve. And next, lastly is the actuator itself. So actuator, hydraulic and pneumatic is same thing. We have the single acting actuator and also double acting actuator. Okay. So if you look at the book, for example in the bottom, the notes, so you can see that we talk about the single acting solenoid, double acting, and then we talk about This is a single acting already explained. So double acting. So sequences. Basically, sequences is just to make sure that the actuator can retract and extend repeatedly. So that is where we have the reciprocating motion. Okay. So you can go through the explanation. Basically, I have explained in the slide. Okay. So next is, okay, this one already explained. Pneumatic double acting actuator already explained this. Skip that. Okay, I want to share to you an advanced pneumatic actuator. We call it as the pneumatic muscle actuator. Okay, so what does it mean? It's exactly what it means. Muscle. Our muscle. Our muscle have lots of tendon, kan? Tendon, atau we call it as fiber lah. Okay, so it's the same way how pneumatic actuator works. Just that it's called as a muscle actuator because how it's being built. It's being built by using fiber. You see here that individual fiber is woven shells. It's not being made by metal, okay, but it's being fiber. It's flexible, much more flexible, and it's really look like a muscle, a human muscle. Okay, so this is example from Festo. They actually design some robotic, like this robotic hand using multiple PMA. So this one is multiple. If you see here, okay, where's my... Okay, if you see here, this one is the first PMA, second, third, fourth PMA. So there are 4 muscle to actually move each finger. So each PMA is to move 1 finger. And if you see here, this one is the tube from the valve, control valve. And basically you see that you have an input valve and output valve. So basically one is input, one is another one is input to it. Okay. And as the end of this, we call it as the piston, the end of the shaft. Okay, we talk about the piston just now. Okay, the end of the shaft. So where is the end of the shaft? This one is the end of the shaft. Okay, this end is where you're going to connect to a load. Okay, load. So all this connection to the load and is all connected to the hinges of the finger. So later in chapter 7, you will learn about mechanism. Okay, mechanism. So what is mechanism? Mechanism is mechanical actuator. So under mechanical actuator, there are lots of type of mechanism. So we have linkages. Example, what you see here is linkages. And we can also look at different types of motion. So mechanism is basically converting motion from rotary motion. Okay, so we have 2 normal motion, general motion lah, rotary. Another one is linear motion. So you might want to convert a rotary motion to a linear motion. Okay. And for the case of this actuator is you have a linear motion. Means that it's moving left and right. Linear motion or reciprocating motion. So you want to convert this linear motion to a rotation. Okay, so why rotation? Because you look at the finger, the movement is not a linear. If it's linear, it's moving like this, but it's rotating at the hinges. Okay, the hinges or linkages. Okay, linkages and hinges. So your finger is moving. So because of that, you need to have a mechanism. So mechanism is always combined with actuator. And what actuator? Normally combined with pneumatic or hydraulic or motor, okay, or electrical actuator. So mechanism is a must in any system. Okay, so converting motion is either from rotary to linear and linear back to rotary. And some is actually converting from rotary to rotary. Example, your bicycle. Okay, bicycle ada berapa gear? Most of the time, like the, for example, road bike. Ada berapa gear? Road bike ada dapat seat VIP. Apa tu Oh, I tak tahulah. Oh, VIP tadi Okay. Apa ni? For example, bicycle. How many gears in your bicycle? My bicycle, I have, you see my bicycle? Nampak tak bicycle I? Nampak tak bicycle I? Tu bicycle I. My bicycle that I bring from Japan is actually a hybrid bike. Dia road bike plus dengan mountain bike. So bicycle normally macam my bicycle dia ada 6 gear sajalah. But most of the time road bike dia ada 12 kot. It depend on the bike lah. So when you have those type of gearing system, then you have a gear train. So you have a gear train, then it's actually converting rotary to rotary. So gear train is actually mechanism. So why you need gear train is because you need more power, or you want to reduce power when you go, for example, more power up the hill or less power going down the hill. So that's why you need the gearing system. Okay. And this is another type of how you can apply this type of pneumatic actuator. Okay, so you see that there's a PMA over here. There are 2 PMA connected to this link, okay, by using a belting system lah, a belting or a wire system. And what happens is that this rotary linear motion is converting the motion from linear to rotation. Okay, so let's look at the motion. Okay, can you see that the motion, the muscle, the PMA muscle is acting exactly like a human muscle. It's contracting and retracting, contracting and retracting. So it's converting from linear motion to rotation. Okay, so very quick video on that. And then I think you can just go through what is the advantage. And this one is just a simple thing. You can go to that. The advantage of pneumatic is, as mentioned, is that it's much more cheaper than fluid, clean, faster, relatively fast than hydraulic. Okay. And the disadvantage is that, for example, like this one, you say that no control of position. Well, I think this was previous in the book. In the book, it says no control of position, but you can actually control the position when it's combined with a controller. Then you can combine it. But if it's applied like that only, using the pneumatic actuator, okay, without any controller, means that you control the pressure only, giving pressure and release it, then there's no controller. But if you want to control it, you need to apply a controller, a PID controller, a closed loop controller. A bit of noise just now, you when you saw the video, okay, it's a bit noisy because of the compressing of the air. And yeah, of course, too many additional accessory. You have the directional control valve, you have the tubing system and so on, you have the compressor, you have the FRL. So many things going into the system. So these are the things that maybe a disadvantage, but people still use pneumatic because of the high force and high torque. So this is example, okay, and I think you can just go through this video, okay, on Festo. Let me just see one video what ni apa I forgot what was the video about. Okay. Yang ni Festo iklan dia banyak on bio robot what robot is this Oh, it's actually half human lah. Okay. This is using pneumatic actuator Okay, this is example of a rotary pneumatic actuator Okay, pneumatic actuator but rotary type. Okay. So, can you hear the music? Okay. Boleh dengar? So, if you see here, okay, this is are the component inside the robot, the bionic robot. So, you see that there's a pressure sensor, basically. Anything, if you want to control it, you need to have a sensor. Then, you have just now I was mentioning about the rotary pneumatic actuator. So, most of the time, they call it, if rotary type actuator, they call it as a rotary vane. Okay, so pneumatic rotary vane. And we have bearings. Actually, bearings means that mechanism inside. So lots of this, most of the time you will have mechanism. Okay, that is one video. I think there's much more interesting video kot. I want, okay, nak tunjuk yang octopus ni. Okay. Okay, so I tak nak tunjuk banyak because we don't have time. So you can just go to the video. Video ni I shared in the PDF. Okay, so let's go to the next one, which is the end of the chapter. So we are going to go through a hydraulic actuator, but mostly the basic system is similar to pneumatic. Just that what I want you to look at later on is on the hydraulic power steering, and later in the mechanism we will also go through again on this hydraulic power steering. So basically, if you see here, there's a car, okay, and the car system, the steering system is either manual or power steering. And the common power steering is using hydraulic actuator or hydraulic system. So basically, you will see that in the car, if you open the front cover of your car, so you will see that there's a system, there's basically a pump to actually compress the hydraulic liquid. Okay, that's why, which we call is as a reservoir, and it's going to control the steering. Okay, it means that you can actually ease off steering when you have this type of system. So go through that video. And also, I want you to go to this rotary operating system, the vane actuator, due to the fact that vane actuator is commonly used, is not commonly used, because most of the time pneumatic and hydraulic, people use linear type, but they will have some cases when you want to use a rotary type actuator. Okay, for example, just now the cobot,
We sold over $500,000 worth of spices.
Go through this video.
So crazy.
I went from selling.
Okay, on the rotary vane, so just go through how does it. I think, yeah, this one, rotary vane. So you look at this rotary vane. What happened is that this red vane is actually pushing in and out depending on the rotation. So at this point is actually low pressure, okay, and it's going to go to a high pressure at the end here, and it's okay, this is maximum air volume. Okay, this is where the air is being compressed, and this is where it's being pressurized. Okay, so just look at the video, watch on how does a rotary actuator principle. Okay, so hydraulic actuator, basically just go through that and then you can read. And this is the typical hydraulic actuator. So you have a reservoir, and normally like in a pneumatic system, you have a compressor kan, compress the air. But for the hydraulic actuator, you have a reservoir, ada liquid lah. So that liquid is being pumped into the accumulator. Accumulator is simply like the FRL. Okay, it's going to compress, filter everything, regulate it, and then you're going to lubricate it. And also next is you go to the valve. Okay, control valve basically. The control valve is to control which position that is going to give the compressed liquid, to the left or right piston. Okay, so basically the same concept as a pneumatic actuator. So just go through this. Okay, and about hydraulic, you can just read the advantage and disadvantage. Okay, and watch this video, okay, before next week, because we are going to go into mechanical actuator next week, and we are going to learn lots of mechanical stuff. So go through that. And lastly, I think this one is not in the slide, but anyway, later we will compare between the hydraulic in the mechanical actuator topic, between the hydraulic and the electrical. So electric motor you will learn in chapters 8, okay, later on. But nowadays, you know that power steering, most of it are electrical power steering. So how does it translate from hydraulic becoming an electrical power steering? Okay, so I think that will be all for today's session. Okay, so before we end, make sure that you do the reflection, feedback. Go to you learn week 7, and down here fill in the form. Okay, feedback form. Alright, any question before we end? Any question? No? No, Alright. Can we just take a picture so that I know my student? Okay, because it's already week 7, but I think right now I do not actually know my student, because we are doing online, so it's a pity, due to this COVID, I do not know you. Okay, you might know me because you see my face. Okay, so those with camera, can you just switch on your camera? Just take a quick photo. Siapa tu? Oh, Syafiq. Syafiq ni memang rajin lah nak reply. Okay, yang lain? Yang lain, please. Yang ada iPad tadi kan? Siapa yang ada iPad tadi? Syafiq yang ada iPad tadi? Nick siapa ya? Azuhairi kan ada iPad? Anyone? Seorang aja? Aduh, Syafiq, okey lah, jom lah kita ambil gambar. Okay. Yang lain tak nak? Okay, alright. Yelah, okay. 1, 2, 3. Alright, so that's all. Thank you very much, Syafiq, for opening your camera. Okay, the rest of the student, please make sure that you fill in the feedback form. And in the feedback form, make sure that you take note lah. If you have question regarding chapter 6, you may write that in the notes. Then later next week, I will try to answer it. Okay, that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye. Oh, kena set up. Okay, next time set up awal-awal. Okay, bye.